Hello, everyone. So today I'm presenting very briefly the Unified Star Schema. So this is the book, the title of the book that I wrote with Bill Inman, and I'm starting the presentation now. So yeah, about myself very quickly, I'm an electronic engineer. I've always worked in the front end, business object, Click, Tableau, Power BI. So I am a front end person. And this is very important because how can I say, all the work that I'm doing is focused on the experience of the business users. Okay, then I worked also in data warehouse like Teradata, and in Prague I was working Teradata in Prague, and then I'm working daily on Snowflake. And now I'm working with the Astrato Analytics. It's a software of business intelligence, and I'm also teaching at the University of Bologna in a school called Bologna Business School. My mission is to make data analytics easier. All right. So this is a screenshot about Astrato. It's the software that we create. It's a beautiful graphics, wonderful. I'm working behind the scenes, so I'm working together with my friend Ralph, who is actually sitting here, and we are working in the back end. So we are doing the R&D of the software. And guess what? Ralph one day told me, Francesco, I read your book, and we should implement the logic of your book inside Astrato. And that's where we are now. So the Astrato is out there, and it is implementing the principles of the book. Okay, so, and this is the school where I'm teaching in Bologna. Okay, part one, I'll talk about data analytics today. Part two, I will tell you about the Unified Star Schema, and then I would like to make a live demo. I don't know if we have much time. Let's see that. So data analytics. So I have always done business intelligence, like I told you, Tableau, Click, but data analytics is also data warehouse, data lake house, machine learning, so data preparation for machine learning, and APIs especially. So all the, basically, the focus is on business intelligence, but the Unified Star Schema, USS, Unified Star Schema, applies to all of the above. So that's also why I like to widen. Now today is very big, but normally this is an event where you exchange ideas with people. So the whole point here is that later during a break or something, it's good if you come and say, oh, so I'm working machine learning, we can talk about that. I like networking and brainstorming together. I need your help to bring ideas to become more true. So the enterprise reports, this is what I do as a job. They look nice, but they are static. Users typically can only refresh the data and apply filters. So it's not exactly much freedom. So, and especially someone else has already decided what information is there, right? So an enterprise report is typically based on a star schema or a snowflake schema or a flat table. This is the data structure which is behind. A star schema looks like this. This is an image I searched on the web, and then I later realized that it was from the website of Kebula. So it's one of the sponsors today, but it was a coincidence. So this is a star schema. There is a fact table in the middle. Let's see if you see my mouse. Yes. So this is a fact table, and these are dimension tables. It's called star schema because it looks like a star. And the idea is that when you have a star schema, you just watch one subject. You can watch the sales, you can watch the returns, you can watch the warehouse, but only one subject at a time. And that's the big thing that I'm working on. I want to go beyond this. This is a Snowflake schema. Snowflake is the name of a software, but nothing to do with that. It's a data structure called Snowflake because it looks like a snowflake, more or less, with a bit of fantasy. So it's very similar to the star schema. So again, in the middle of the Snowflake schema, there is always a fact table. And again, last thing, flat table is just a big CSV file. So again, in all the three cases, you're just watching one business domain. All right, so, and the other problem is that these structures are prepared ad hoc by a data expert. So they are created because you are a business user and you say, I want to see this, and some data analyst is writing code and then is preparing these structures. That's why reports today are static, because they're based on a structure that is also static, because it needs to be created ad hoc for a particular request. So instead, that's how self-service analytics should be. It should be like e-commerce. When you go to a website of e-commerce, don't go too much. When you go to a website of e-commerce, you just type what you want, and then you buy it. And then you have no limitations. Whatever you want, if it's available, you can buy it. So in e-commerce, self-service is available to everyone. Self-service. You go there and you pick what you want. An equivalent in data analytics, unfortunately, today does not exist. So these are the market leaders: Qlik, Tableau, Power BI, Looker. I added ThoughtSpot, that's less known, but ThoughtSpot was promising that you speak in English to the software and then you see your data. Yeah, but they all promise a dream, but the reality is very different. So they are all beautiful, they have colors, but they don't deliver the same freedom that you would have when you do shopping online, when you are searching things and you are picking whatever you want and you add it to your cart. This does not exist today, and that's where I want to go. So, who of you knows where this image comes from? Sorry? IT crowd, exactly. So this is an example of business users. So they are two girls in the higher floors, the ones with the lights, and the IT guys are downstairs in the basement trying to write code. This is the reality today, right? So why business users do not have access to self-service analytics? Why they cannot do like buying shoes? Because data looks like this. So data is ugly. It's a tangle of tables, and the data that you need, it may be a bit of table, a bit of data could be in this table, and a bit of data could be in this table. So that's the problem, because you don't, well, in a phrase, business users do not make joins. So when you have data in two tables, you need to create joins, but business users don't do this. So that's why we need something that goes beyond this problem. So the truth about today's self-service analytics is that everything is in the hands of these two guys. So the IT guys, they are in the basement, but they rule the world. So and this is a thing I want to change, not because I have anything against them. I was also doing their job, sometimes also in a basement, but because they deserve something better. They need to have more fun. We all need to have more fun. We cannot just have a person there to do ad hoc, a report that is connecting sales with clients. That's boring. We have a lot of problems to solve. So let's get automatic solutions, do the automatic jobs, and let's use the brains of our IT people for something that is better, that is smarter, because we are not running short of problems to solve. So that's the idea. So let's focus on a simplified data set. I don't know how much time I have. Anyway, I just tell you very briefly. This is an example where I took two fact tables, just to give you an example, that you have, she said, so I have 1 minute. So basically, okay. You have a fact table of internet sales and another fact table of reseller sales. So this is an example. You remember the star schema earlier. So they would be two star schemas. And when you have a report, it's either watching the internet sales or it's watching the reseller sales. I guess reseller sales means that you're selling to some wholesale company that is distributing. So basically you watch either one or the other. So can we do something better? So then we have, for example, two dimensions. So we have two fact tables, then two non-shared dimensions. So the dimension customer only makes sense with the internet sales. So it's more or less like you, the user of Amazon, for example. And the dimension reseller makes sense only when you talk about reseller sales, meaning that it's a company that is buying a big lot and then is distributing. But then there are two shared dimensions, which is the product. So you're selling the same product through these two channels, and the promotion. It's a database like that. So you can apply the same promotion through the two channels. And also there's a product hierarchy. So basically a product subcategory and product category. Okay, so this is a very, very simplified version of what you saw earlier. But despite being simple, shows us some major challenges. And okay, now I made a list. That's too boring. I just read the first. Imagine that you want to see the internet sales amount by product category. That's an example of a report that you may want to have. And then there's another, you may want to have the reseller sales amount by product category and maybe by promotion category, and so on. So these are 5 examples of a report that people may want. They all sound similar. However, for example, when you use Tableau, they require 5 different data models. So in other way, so basically for each of these reports, you need to connect the wires behind the Tableau in a different way. And that's what a business user would not do. So the problem is that we rely upon the guys in the basement because for 5 reports, we have 5 different architectures behind the scene. And that's the bottleneck. So now I gave you some screenshots. Report 1, trust me, this is the data model. Report 2, trust me, this is the data model. Report 3, the ones that we were listed, is this data model. So it's the same things, same ingredients, connected in a different way. And that's impossible for a business user. And then this, and then, oh, that's the most funny one. So this, in particular, internet sales amount and reseller sales amount by product category and by promotion category, it's a scenario of 2 fact tables sharing 2 dimensions. And this, it's a normal request, but as of today, Tableau is not able to do this. Although this is the foundation of Kimball dimensional modeling, it's the most normal thing that you can have, the most normal request that you can have on a report. But Tableau does not support it. Okay, so this is a problem. Can we improve this nightmare? Because trust me, it's a nightmare. People are asking for a report and then they're waiting a few weeks and then the developer, okay, starting coding, you need to allocate a budget and then there is the testing phase, the test is failing, then it goes back to developer. It's a nightmare. So it's too slow and too expensive. So Tableau is trying to build a solution. This is a GIF, animated GIF that I found from the website of Interworks. They are planning to do this, which will solve that famous report number 5 that I showed you a minute ago. But it's not there yet. So it's in the roadmap, but it does not exist yet. So what is the Unified Star Schema? So as Bill told you some time ago, we decided to write this book together. Actually, we didn't decide. He said, you must write a book. And I said, okay, Bill, okay, I will write a book. So this is a photo we took in the US. I spent a week with him in Denver, Colorado, and we were discussing about the book and everything. And this book, basically, the idea of the Unified Star Schema is that there should be one star schema that is structured like the one you saw before, but it's a bit different because at the center of the star schema, there is a table called the bridge. And then Bill said, you shouldn't call it the bridge, you should call it the Puppini bridge. So it's called the Puppini bridge. So this is an image I took from an article that some guy wrote about the book, because he saw a book written by Bill Inman and some Italian guy, and he made a review on Medium and towards data science. So the idea is that that tangle that you had before becomes simplified, because it's always the same. You put the Puppini bridge in the middle and all the other things all around. That's the Unified Star Schema. So I wanted to give a live demo. I don't think we have much time for that. But the outcome of that is that, for example, in Tableau, you put the Puppini bridge, and then you put all these tables. Now Tableau is putting them on the right. Normally, you can put them all around. But the idea, yeah? Okay. Oh, we have time. So the idea is that it's all connected to the bridge. So one data model satisfies 5 reports. You remember earlier, I showed you 5 reports, and I said for each of them, you need a different data model. Now, with the Unified Star Schema, this is the data model that satisfies all 5 reports, including the 5th one, the one that Tableau today is not able to deliver. So with the same Tableau that companies have, they have adopted, they are paying the license, and they cannot deliver that report. If you build the Puppini bridge, that report, which was impossible, it becomes possible. Of course, it's still possible if you do data transformations. For example, you want that report, you really want it. Okay, you go to the guy in the basement and you say, okay, can you please write the code? So the guy will write some code, and then it will be possible to have the report number 5, but not the business users. So with this, the business users can have that same result without going to the guys in the basement to ask for some development. So basically, instead of having this, we have this. So this is a schema of the same data model that is like this, and is more complicated. Now it is extremely simplified, because you just connect everything to the bridge. Okay, so because we have time, I've prepared in Tableau. I already made the connection to my Snowflake account, and I will show you how easy is the experience of making a report. So I go to the data source of Tableau, yeah. And If I am in the normal schema, this one, what I have to do, for example, imagine I want to see the internet sales amount by product category. I'm a business user. So what do? I scroll, I search. It's difficult. So I see, okay, fact. Okay, so I go to search. So I find that there is something called internet sales. This one, okay, it's probably this one. Yeah, I'm a business user. I think it's there. But then especially, I say, okay, I want the product category. So I go here and I search product, okay, product category. I find it. Think about the shopping. When you are doing the shopping, you just pick what you want if it's available in the shop. So in theory, if I think with the mindset of a business user, I would say, okay, I want product category. So I double click. These are the two things that I want, sum of sales amount by product category. But Tableau is saying, well, I don't know how to join these two things. Then panic. I'm a business user. I didn't study these things. So I try to see if they connect. They don't connect. So basically, the user should find where the internet sales are, and then he or she should find where the product category is, and they should find a path to go from one to the other. This is the biggest problem, because today, instead, when you go to Tableau and you want to create that connection, you today must go to search product. So you select the product and you connect internet sales to product. And then you must connect the product to the subcategory. And then after that, you finally can connect to the product category. This is what a business user will never do because it's too complicated. If you want two things in an e-shop, you get one thing and then you get the other thing. Here you should get the things that are in the middle. Now I show you that instead, if you don't use the data source as it is, but you go to the transformed data source, which is called AdventureWorks Unified Star Schema, now it's much easier. You're a business user, they tell you, rule number one, you start with the Puppini bridge. Okay, now I called it bridge. So you start with that. And then you want to see the internet sales. So you go and you go to stake internet sales. You double click, you lift your hands, you don't need to worry about the join, and they're joining. And then you want to see the product category. So you double click on that, and it is working. Because the Puppini bridge inside already knows that from going from the original internet sales, you need to go to product and then subcategory and that category. It's already building that mapping in the Puppini bridge. So the experience of the business user is that they just take what they need. They don't need to take the intermediate steps. This is the big advantage. And then they can add anything. Click on this. It's adding to the schema. You want to click on finally on the reseller information. And be careful, the reseller information now is incompatible with the internet sales. So not everything connects to everything by nature. There are business areas that don't talk to each other. But in this case, the Unified Star Schema doesn't give an error. It simply puts the result in a separate rows because the reseller information has nothing to do with the internet sales. But then you can also add now very easily also the reseller sales. So basically, the principle is very simple. Whatever you need, you just drag it in like if it was your cart, and then you can consume your data. Okay, so I think this is pretty much what I wanted to show, except, okay, now because I showed it. If these two cans were tables, this is a union, no, this is a join, and this is a union. So basically, the union is the hard operation that you have in the Unified Star Schema. So things are not next to each other, but on top of each other. It's just a different command of SQL, but that's the key principle. And I want to show you that this operation of the union is making things easier, because if I go, for example, I show you also the bridge, how it is. The bridge is a table that looks like this. So it's a table, sorry. It's a table that organizes the information in stages. So that's a smaller version of the data, but you have the stage of internet sales, the stage of reseller sales, and whenever two things are by their nature, they are connected to each other, the box is filled. But when the box is empty, it means that they don't have a correlation to each other. This is the Puppini bridge. Very last thing that I want to show you is that we also implemented the Unified Star Schema in Astrato. Why I find this so important? Well, my mission is to make life of people simpler. So I made an example where I create this data model. So I click, for example, on a connection that I've already prepared, which is connected to the same thing you've seen earlier. So this one, and I create now the connection to this data source, and I don't need even the Puppini bridge in Astrato, because that bridge table that someone needs to create on the data warehouse, Astrato is creating it for you on the fly. So when you want to select some information, for example, I go to AdventureWorks, the original one, the one that is not transformed. And I start selecting things like fact reseller sales, and then I take fact internet sales, this one, internet sales, and then I can put a dimension promotion, and then I can put a dimension product, and then I can put a dimension reseller. I guess it's enough. So now that I've selected these tables, I just press a button, and the engine behind is applying a couple of the principles of the Unified Star Schema. First of all, it's treating every connection between two tables with the graph theory of oriented graphs. And for this reason, it's able to suggest the joins, and it's also telling the quality of the joins. In this case, they are all good. I apply all the joins, and I don't do anything. Astrato is automatically understanding how things are connected, and it's automatically understanding how to display the arrows always from left to right. I know I'm going very fast. It would require more time. This is sort of a teaser. I'm showing you what we have created. And the advantage of this is that the user experience now becomes very easy, because, again, the users have the freedom of behaving like in e-commerce, but this time there's not even a Puppini bridge behind. So if I take a dimension, for example, I take the promotion, English promotion category, yeah, for example, and then I take, for example, another dimension that could be the English, what was it, the product name. No, I wanted something different. The product, okay, let's find the product name. And then now I'm adding the measures. So I can add the sales amount. I search by text. So sales amount, sum of sales amount. And then I'm adding even one more measure. And I put in this case, the reseller sales amount. Okay. This, what you have seen, is a Puppini bridge hidden in the code. So the code is automatically creating the union, which is the operation that is piling up those cans of beer. So this union all is basically the magic of the Puppini bridge. It's like those two cans of beer, one on top of each other. I know it's not understandable like that, but it's just to tell you that all the steps of arriving to a universal solution that is easy for business user. First, it was implemented through the Puppini bridge, and now we are even doing it without the Puppini bridge, because we are applying those principles in the software. So I guess it was a bit tough to follow. It was even a bit tough for me, but thank you so much for listening to me, and I'll see you later. Thank you.